vehicle that glides over the smooth surface by hovering upon an air cushion. Because of this, a hovercraft is also called an air cushion vehicle. The hovercraft creates a vent of air, which are trapped beneath the vehicle by a curtain surrounding the base. This curtain of air can create an air cushion, so any smooth surface, land or water. Since a hovercraft can travel upon the surface of water, so it's also called an amphibious vehicle.
Electrical engineering goes into the connecting the power source such as the battery to the fan. We would have to rewire and understand what circuit completes which action. The form of the craft itself and the bonding of all the parts deals with the mechanical and materials engineering, because we have to find the strongest yet lightest materials for our hovercraft.
The first item on our list is the foam. The foam is used for the body of our hovercraft. Next, we use tarp. The tarp is used as the skirt for the hovercraft. After that, we use two fans. One fan is used for lift off the ground, and the other fan is used for movement of the hovercraft. To power the fans, we use batteries. We use 4 9-volt batteries to operate them. Battery connectors were used to create the circuit for the batteries. We also use the box cutter. This was very helpful in getting out the shape of our design. We use duct tape to seal off any unwanted air, a compass to precisely draw even circles in the foam, and then scissors and rulers.
Using the compass, we first figure out a diameter we want for the top of our hovercraft. Then, we use the ruler to create the dimensions for the body of the hovercraft. We then take the compass to create an inner circle for where the fan would be to place air in the skirt. We would then take the tarp and the shape we cut out and the ruler to create the same exact shape on the tarp, only 4 inches bigger. After drawing out the shape on the tarp, you would then just cut out the exact line that you drew. After you cut it out, this is what it should look like. You would then fold over the tarp over the object, leaving about 1 inch of space, which is where the air from the fan will go, and taping it to the object. You would then tape the fan over top of the hole and connecting the fan to the battery connector, which connects to the battery.
As we constructed our first hovercraft, we soon found out that the weight of the fan and the board was too heavy. As we turned on the fan, the hovercraft would not lift off the surface of the ground due to the heaviness of the fan. But when we lifted the fan from the top surface of the hovercraft would then lift off the ground. Engineers learn from their mistakes and improve as they continue through the design process. So we tried to improve our first hovercraft. We then shifted to a much more powerful fan in hopes of making it move.
We now use the hair blower as our fan, since it has a much powerful motor and produces more air. But now our next problem is to get it to move. We started with little small cuts in the tarp to get it to move, but we then noticed to make it move better, we would then have to make a bigger hole at the bottom of the tarp to reduce less friction from the surface of the ground to the tarp itself. This idea would definitely encourage students to enter into the STEM field, which is the science, technology, engineering, and mathematics field. Hovercrafts is an extremely cool idea that has been exaggerated in many movies and in television. It shows that these fields can allow you to engineer many fascinating things. We think that by building the small craft, it will help bridge ideas towards making an even bigger craft, which can expand kids' minds. All in all, we would like to make it possible for students to become involved in a hands-on engineering experience. We believe that by doing, students will get more excited about engineering because it creates a sense of possibility in their minds.